You're welcome to my channel. In this video, I'm going to be solving this equation, which is k raised to the power of k is equal to 17. Now, if we have to get the value of k, we can just do a test to be sure of what we should be expecting, the range with which the value of k will lie. And we do that by picking a whole number and raising that whole number by itself. And let's see the range that the value of k will lie. So let's start with 2 raised to the power of 2. What's 2 raised to the power of 2? That's what? 4. Not up to 17, right? And let's try 3 raised to the power of 3. Again, 3 raised to the power of 3 because it has to be the same. The base and the exponent have to be the same. So 3 raised to the power of 3 is what? 27. And this is more than 17. So what does this mean? It means that the value of k will lie between 2 and 3. Yes, so it is safe to say that k will lie between 2 and 3. We'll start by applying the natural logarithm to both sides of the equation. Now, the reason for that is to put this raised to the power k down. So let me just say, take the natural logarithm, that's ln, to both sides. So I'm going to have ln k raised to the power k is equal to ln 17. Now moving on, I'll take this k, that's from one of the logarithm laws. This k is going to multiply the logarithm. That would be k ln k is equal to ln 17. So, but even if we divide both sides by ln k, all right, we'll have k here, but we have ln k as well. And we cannot solve this algebraically. We'll only have to use the Lambert W function. Let me say that again. We are going to be using the Lambert W function. How does the Lambert function work? Let me show you something. The Lambert function denoted with the letter W. If you have the Lambert function being applied to something like this, A, like this, the result will be equal to A. Also, if you apply the Lambert W function to, let's say, 2 or let's say 7, E7 is going to be what? 7. Notice something. The coefficient of E and the exponent here, they are the same. Same as what we have here, A and A. So the Lambert W function of 2E raised to the power 2 will be 2. The Lambert W function of 10E raised to the power 10 will also be 10. So that's exactly what we are going to do here. We cannot solve this algebraically. So let's apply the Lambert W function. But first, we need to introduce E into this equation. As you can see, there's no E there. We only have the natural logarithm. That brings us again to one of the things you have to know about exponent and logarithms. They are inverse functions. So let me just rewrite the equation. K ln k is equal to ln 17. We don't have E here. And we know that the Lambert W function is this. Basically, you have E in the function. So how do we bring in E into this? Since we know that E and ln are inverse functions, and if you have E raised to the power of ln x, for instance, you know that ln is actually natural logarithm. It's a logarithm with a base of E. So let me just, we can rewrite this as what? E log is E of x. So because the base of the logarithm here is E and the general base is also E, we can cancel out. Notice they are inverse function, logarithm and E. So when they cancel out, what do you have? X. So it means that if I have to introduce E into this equation, I will replace K. I'm going to say K is equal to E ln K, because the natural logarithm and E will cancel out and you have K back. So because we need to introduce E into this equation, I will have to substitute K for what? E ln K. Let's do that. So that will be what? E ln K, then ln K again is equal to ln 17. This makes so much sense. It's almost close to us having that structure where we can apply the Lambert W function. So I'm going to take this ln k behind e. It doesn't change anything. It's commutative. So ln k e ln k is equal to ln 17. Good news, good news, good news. We can now apply the Lambert W function. Why? Because the coefficient of e and the power here, they are identical, they are the same. So we'll now bring in the Lambert W function. W and then ln k e raised to power ln k is equal to the W function again of what? Ln 17. Beautiful. Now, the Lambert W function applied to this will basically be what? Ln k. And this is equal to what? The Lambert W function of ln 17. But since we need to get the value of k and not ln, we are going to take e to both sides. Remember, e is an inverse function to ln. So I'm going to write it like this. E, then ln k is equal to e again. I just applied e to both sides. So notice something. Ln will get rid of e, and then I just have k, which is equal to what? E, then the Lambert W function of ln 17. Good, good. So this is the value of k. Approximately k will be 2.775. Now, as you can see, this value lies between 2 and 3. As I said before, it's going to be 2 point something. So approximately again, the value of k is 2.775. If you put this into a calculator, 2.775 raised to the power of 2.775, you are going to get 16.9846, which, if you decide to round this up even to one decimal place, it rounds off to what? 17. I hope you enjoyed this video. If you did, kindly subscribe to this channel for more content like this, and don't forget to share this video with your friends and family. I will see you in the next one, and it's bye for now.